5, 4, 3, main engine start, 2, 1, and 0, and liftoff of Messenger on NASA's mission to Mercury.
NASA's Messenger spacecraft will become the first probe to orbit Mercury.
Getting a spacecraft into orbit around Mercury is difficult for two reasons: the sun and the sun. The sun as a source of heat, and the sun as a source of gravity.
To sneak past the sun, Messenger is taking a convoluted route, flying past the Earth once, Venus twice, and Mercury itself 3 times to arrive in full-time orbit by 2011.
When you get into orbit, you can end up mapping the whole planet at fairly high resolution. So we will start having a mature and fundamental understanding of Mercury, not only its surface, but its whole chemistry throughout the whole planet. From that, we can unravel to some degree how it formed.
What other secrets are etched into Mercury's ancient surface? Already, Messenger has sent back some curious clues.
Engines beginning.
Arriving at Mercury, there's a list of natural wonders to see, and even a dazzling light show.
And liftoff.
After Messenger's 3 flybys, we've now mapped more than 90% of the planet. Taken from around 124 miles, these images are the clearest to date of Mercury. And it's not hard to spot a crater of epic proportions, the result of yet another titanic collision.
That's the Caloris Basin, this impact basin. It covers almost 3 million square kilometers. It's one of the biggest in the solar system.
The size of Alaska and California combined, whatever created Caloris almost destroyed the planet.
It was, something in the order of 100 kilometers in size. It could have been a huge comet, or it could have been a very large asteroid. It had a catastrophic effect on the surface.
Shock waves rippled around the crust, buckling it on the opposite side. And near the center of the crater is another spectacular geological puzzle that has experts scratching their heads.
The spider is this really strange feature that's in almost the center of the Caloris Basin.
Oh, the spider, it really annoys me when I hear people call it, because it doesn't look like a spider. How many legs does a spider have? 8, right?
It looks kind of like a 100-legged spider, but it has all of these radiating cracks coming out of it.
Whether the spider is the result of planetary stretch marks or some obscure cratering process, no one knows.
It's a fascinating feature. We don't know how it formed. It's very tantalizing.
So, for a planet that appears inactive, more has been going on deep inside Mercury than we ever gave it credit for. There's even more occurring above the surface that can't be seen. And it involves the relentless force of the sun. Like Mercury, the Earth takes a beating from the sun's violent temper. Flares, sunstorms, and other solar hissy fits can cause electronic mayhem for the satellites that roam above our heads. Fortunately, the Earth is protected from this radiation by a magnetic shield, a kind of force field generated by our molten iron core.
Planetary magnetic fields shield planets, their surfaces, and their atmospheres from charged particles that are always coming off of the sun.
The auroras that light up our polar skies are evidence of our protective shield at work. Without it, life would not exist here. Visit Mercury, and you'll be visiting the only other planet in the inner solar system with a magnetic field. But its very existence defies explanation.
Now, the mystery there is that in order to have a magnetic field, you need to have an interior to the planet that is at least partially molten. Mercury, one of the smallest of the planets, would have been expected to really have frozen all the way through. And yet we have a relatively strong, very well-defined magnetic field that appears to have a source that's located deep in the planet.
Whatever mechanism is driving Mercury's magnetic field, it's too weak to protect it from the full force of the sun. The solar wind buffets Mercury's thin atmosphere, and in the process, it puts on a light show.
The reason you'd want to go to Mercury as a travel destination would be this night side view, because it's going to be highly unique in the solar system. You have sodium atoms that are streaming off and giving off this yellow light, so you could almost look as like you're standing in a donut of sodium emission.
With the sunrise 3 months away, you'll have plenty of time to sit back and take in the view, framed in a halo of amber light.
In some sense, you could get a very nice light show, and I know people go to Canada to look at the northern lights all the time, and so that would be a reason to go to Mercury.
T-minus 40 seconds, everything looks good for launch.
Not a night owl? Then head into the light. But when you're this close to a stellar rotisserie, make sure you pack plenty of sunscreen. If you want a suntan, you can't beat the dusty sands of Mercury. Stretch out on the ground here, and the sun crackles and fizzes right above you, appearing almost 3 times bigger in the sky and 7 times as hot.
If you were walking on the surface of Mercury, you would need one heck of a spacesuit, because if you were in the sun, it would be extremely hot. You would see an enormous sun in the sky that would just, burn you to death if you, spent any time in it whatsoever.
The Mercury really climbs on Mercury to a toasty 840 degrees Fahrenheit. That's about twice as hot as your kitchen oven on full heat. You'll need a bit more than SPF 30 sunscreen here. To escape the heat, you can always head to the dark side, but dress warmly. With virtually no atmosphere to keep the heat in, the temperature plummets to minus 275 degrees Fahrenheit. And it's here in the freezer that Messenger will encounter another puzzle. Can ice exist on a planet so close to the sun?
It was only when the first radar observations of the surface of Mercury were obtained, back in the 90s, that it was discovered that Mercury, in fact, had what appeared to be polar caps in these first radar images.
Some corners of Mercury's polar craters are in permanent shadow. Here, on the most sun-baked planet of all, water seems to survive frozen in eternal darkness.
The ice is contained in places where literally the sun never shines. And so the ice is sequestered in these dark interiors of craters at the high latitude regions.
We found the same thing on our moon.